We're going to start with number 15. So the first thing I'm going to do is I'm going to write my given, and I'm going to write my find, because I'm going to do that on every single problem. So I'm going to chunk it. I'm going to read it slowly. So it says a 70 kilogram astronaut, so mass is equal to 70 kilograms, is standing on a scale in a spaceship. So this is a classic physics problem. You have somebody standing on a bathroom scale. We're going to do this next week in our lab. We're going to go on the elevator and we're going to stand on a scale. And we talked about this yesterday. Okay? So what I'm going to do is I'm going to keep reading the problem. So he's moving in a straight line with a constant velocity of 100 meters per second. So if the velocity is constant, in that particular case, that means the acceleration is 0. And it says at that point the scale reads, so the reading on the scale reads 300 newtons. The ship then accelerates, so then it accelerates at 7 meters per second squared. So now it says, what does the scale read now? So now I want to find the new reading on the scale. So the first thing that I'm going to do is I'm going to draw a free body diagram. So a free body diagram shows all the forces acting on an object. So I'm going to use a box to represent the astronaut. Now he's standing on the scale, so I'm just going to draw a little line showing that there's a contact force between his feet and the scale. I'm going to draw a dot in the middle to represent the center of mass. And a free body diagram is only going to show all the forces acting in the direction in which they act. I just want to be aware of what sign convention I'm using. So I'm using my same standard Cartesian sign convention that up and to the right is positive. Now, his weight is going to act straight down. So his weight, F of G, is going to be mg. Now, we did a lab yesterday, and the lab that we did was we had our hand pushing on the desk, and the desk exerted an equal and opposite force on our hand, and that was our normal force. So now we're going to draw our normal force here. So he's standing on the bathroom scale, and the scale is exerting an equal and opposite force on his feet, and that's the normal force. The key to doing these problems is that the reading on the scale is actually the normal force. That is the key to these, what we call in physics, classic elevator problems. The reading on the scale is the normal force. Now, what did we do? We learned that F net is equal to ma. That's Newton's second law. That's what we learned. So what we're going to do right now is we're going to apply Newton's second law. So F net, all the forces going in a particular direction, is equal to ma. The only forces we have going are in the y direction. So what I'm going to do is first, I'm going to draw my sign convention. So I'm drawing a plus and an up arrow, because that means that I'm going to call up positive. Then I'm going to draw this. This is sigma. So that means adding up. So now all this is saying is I'm calling up positive, and I'm going to add up all my forces going in the y direction. And that should be equal to ma. So all I did here was, instead of writing F net, I wrote my sign convention, and this just says I'm adding up all my forces going in the y direction, and that's equal to ma. So that's applying Newton's second law in the y direction. So now I'm going to go like this, and now I'm going to look over here at my free body diagram. So my free body diagram, I'm going to look at it. So the first one I see is Fn, the normal force, and that, is it going up or is it going down? It's going up. So up is positive, Fn. Then I'm going to look at my only other force here, which is the weight, and that's pointing down. So this is going to be minus F of G, and that's equal to ma. So remember, the normal force is what I want to solve for because that's the reading on the scale. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So Fn is equal to ma plus Fg. All I did was take this Fg and I moved it to the other side of the equal sign. Now I'm going to go ahead and substitute in my values. So I'll say Fn is equal to the m, 70 kilograms, times the acceleration, 7 meters per second squared, plus the reading on the scale, which they already told me the scale reading was his weight, so that was 300 newtons. So in my given, I probably should have called this F of G because that was his weight. They said, because remember, he was moving at a constant velocity and the acceleration was 0. So Fn is equal to 7 times 7 is 49, so 490 newtons plus 390 newtons. So my answer is 790 newtons. And remember, a kilogram meter per second squared is a newton. So my units work out and I can add everything together. This is going up. This is positive. Okay? We already took this into so this is the reading on the scale, and that's the normal force. All right, now let's look at number 17. So we're going to write our given, and we're going to write our find. It says a ball acquires a speed. So if it's acquiring a speed, that means that they really didn't start off with that speed. So we'll say Vf is equal to 12 and Vi is equal to 0. When a force is applied for a distance of 0.5 meters, so x is equal to 0.5 meters. If the ball has a mass of 1 kilogram, you see how I'm chunking? I'm reading one thing at a time and writing it down. What is the force applied? So I want to find F. So what I'm going to do is, first I'm going to write Newton's second law. I'm going to say F is equal to ma. Now I could write F net is equal to ma, but in this case there's only one force. So that's why I could just write, if I want, F is equal to ma. Now I'm going to look at my given. Am I given the mass? Yes. Am I given the acceleration? No. But can I take all this stuff and find the acceleration? So I have Vf, I have Vi, I have x, and I want to find a. So now I'm going to look back at my kinematic equations, and I'm going to say, is there any equation that has those 4 variables? And the answer is yes. So my equation is Vf squared is equal to Vi squared plus 2ax. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So Vf squared minus Vi squared over 2x is equal to a. So that's equal to 12.
Can you send them?
So this is equal to 12 meters per second squared over 2 times 0.50. Okay? So 12 squared divided by 1, so 12 squared is 144. Meters per second squared. So that's my acceleration. Now I'm going to go back to my original equation and say F is equal to ma. So it's equal to 1 kilogram times 144 meters per second squared So that's 144 kilogram meter per second squared, which is 144 newtons. And that's it. So step by step, that's why it's important to write your given, write your find, write your basic equation, and you're going to do a systematic approach to solving the problem, and then it solves itself.